Well, hello, geometry. Happy whatever day it is that you're watching this. I hope that you're having a good one. Here's a little warm-up for you. It is very much like the kind of thing that we had in the last video using the midpoint formula. So go ahead and pause this and see what you can remember about solving these kinds of problems. Alrighty. So in the last video, we talked about the midpoint formula, and essentially it was a recipe for finding midpoints. Early on in the video, we discussed how we had to calculate midpoints because really geometry is all about being exact. And if we don't even have a look at this segment as we have in this warm-up, we can't even see it. We don't want to pull out graph paper and plot it and then try to eyeball the midpoint. It's just not good enough. But it turns out that we have something that will help us calculate the midpoint every time, and it's called the midpoint formula. It looks like this: x1 plus x2 over 2, and then y1 plus y2 over 2. Now these aren't separate ideas. What you're calculating here is a point, a midpoint. And so it will look like a point also. All points are wrapped up in parentheses, and your x part is separated from your y part with a comma. And so that's why your formula looks like that, because once you get done calculating, you're going to end up at a point. So all of this x1, x2, y1, y2 is just the numbers that are in the endpoints. These are the values of the x's and the y's in the endpoints. And we could call this point x1 and y1 because it's the first one. And then we could call this one x2 and y2, being very careful that we know that the first number are the x's and the second number are the y's, and that's where we're going to take the numbers to plug into the formula. So when we're operating with this formula, we're just going to kind of keep the structure of it, so some parentheses, and then we're going to take the number that corresponds to x1. Well, in this particular problem, you see that we labeled x1 as 2, and so we have 2. And then the formula says to add, and now be careful, don't drop this one in there because it's a y value. You wanted the x2 value. Instead, oops, I can't erase that, but that's okay. We want this one because that's the x2 value, so 1. And then the formula says to put that all over 2, and so we will, and then a comma. Now we want that y1, 1, plus the y2 value, which is 4. And put that all over 2 like the formula says, and then wrap it up in some parentheses. Now it's just a matter of doing a little bit of arithmetic to simplify this. 2 plus 1 on top gives us 3 over that 2. Don't forget your parentheses. Comma, 1 plus 4 on top is 5 over 2, and end parentheses. Now, as far as I'm concerned, this is just the most beautiful thing I've ever seen in my life. I love mixed fractions. I think they are, sorry, not mixed, improper fractions. They're the exact answer. If you must change this into a decimal, then be my guest, but you don't have to. That is just a perfect answer. And 3 halves, 5 halves is the midpoint of segment JK. That's what the midpoint formula does. You take the endpoints, you jam them in the right spot in the formula, and then you calculate down and find your midpoint. So we're going to build on the idea of formulas today and do a little exploration that builds us what's a new formula and then use that formula. But before we get there, it's time to update your notebook. So get it out, write some questions, write a summary, and then get a new note page started. Go ahead and pause and take care of that biz. Okay, here we go. New notes. Your topic today is the distance formula. Another formula. Formulas are like recipes. You just do what they tell you, and it comes out with what you want at the end. The topic, the distance formula, the essential question, how can you find the length of a line segment in a coordinate plane? The last video we were finding the midpoint of a segment. Now we're trying to figure out how long the segment is in a coordinate plane. Make sure that topic makes it into the table of contents of your notebook, and let's press on. So hopefully you remember the Pythagorean theorem, because I'm going to do a little bit of experimenting with you. This is not something you're going to necessarily need to know, but I'd like to show you how we get the distance formula. If you remember, the Pythagorean theorem looks like this: a squared plus b squared equals c squared, and it's useful in right triangles. This is not something you necessarily need to have in your notes, but if you have a right triangle, one side is A, one side is B, and the hypotenuse is C. If you take the value of A and square it, and then add that to the value of B and square it, you're going to get the value of C squared. And so you can find the length of any of those segments, A, B, and C, in a right triangle using that formula. It's like a recipe for finding out what you want. So let's keep that in mind as we move forward. It would be useful to have this in your notebook, the distance formula. This formula is useful to find the distance between a pair of points in the coordinate plane. So that's what you should put in your notes. Then put down your pencil once you get done writing that, and just watch me build the the distance formula. And then I'll tell you when to pick up your pencil again, okay? So here's the idea. If you want to find the distance between 2 points that are fairly close on a coordinate plane, it's not too tricky to do that. But if you want to find the distance between 2 points that are very far apart, you might not have a big enough piece of graph paper in order to calculate how far apart they are. And that's when the distance formula can come in really, really handy. It can also help you in lots of other ways that I won't go on and on about. For example, what is the distance between the points A at 1534 and B at 4270? We're going to use the Pythagorean theorem in a new way in order to get this taken care of. So first of all, let's take a look at this right triangle. If we want to find the length of this red segment, we could potentially use the Pythagorean theorem. In other words, if we knew the length of A and we knew the length of B, we could say that a squared plus b squared equals c squared and find that length. But the problem is we don't know the length of A and B. Actually, we kind of do. Let's take a look at A. If I want to find its length, I can notice that there are two x values here. There's a 15 and there's a 42. So 15 is the x value at that point, and 42 is the x value at that point. And if we want to find the length in between 15 and 42, we could just subtract 42 minus 15, correct? Wouldn't that give us that length? So if we take 42 and we subtract 15, we get 27. So now we know that this side is 27 units long. Clever, yeah? Now what if we wanted to find the length of B? We do, because if we're going to use the Pythagorean theorem, we're going to have to find its length as well. Well, notice that it's a vertical segment. And so, what do you suggest we do? Let's look at the y values. It's 34 here and 70 there, so 34 here and 70 there. If you wanted to find the distance between them, you could take 70 and subtract 34, and you would get that distance. 70 minus 34 gives us 36. And so now we know that we could find that length by saying 27 squared, because that's that x side, plus 36 squared, that other side, is going to equal, and let's call it C, the red segment, C squared. And now we could go through some math and figure out what C was. I'm not going to do that. What I'm going to do instead is rewrite this 27 as 42 minus 15, that's the same value, squared, plus 70 minus 34 squared is going to give us C squared. Now the reason why I did that is because we're getting close to seeing how the distance formula works. Just kind of want you to hold on to that idea, that in order to find these numbers, we had to subtract these numbers. Okay, So now we're going to try it without numbers. And again, you don't have to take notes on this. I just want to kind of show you how we get this distance formula. So when you're operating without numbers, you sometimes end up with a formula, so that's what we're going to do. So we're going to do the exact same thing. We are going to find the length of the red segment AB, except this time all we have are x1, y1, x2, y2, the 2 points that are the endpoints of that segment. There's still a right triangle that kind of exists between these two. And if we wanted to find the length of A and the length of B in order to find the length of C, we could still use the Pythagorean theorem, but we're going to have to be a little bit clever. Remember before how we had the distance between the points were the subtraction of the numbers? Well, now we don't have the numbers, but we know that the x value here is x1, and we know that the x value here is x2. And so the length of the x leg is going to be x2 minus x1. Now we don't know what that number is, but we know that that'll give us the length of that leg. We could do the same thing with the y values. We could take y2, which is the value at this y point, and y1 is the value there, and we could subtract them to find the length of the y leg. If we knew those numbers, we could subtract them to find that value. So we would take y2 minus y1 to find the length of the y leg. Now, if we're going to find the length of C, we're going to need the Pythagorean theorem, because we would want a squared plus b squared equals c squared. Well, we know the length of A is this right here. So we could take x2 minus x1 and square it, add that to the b leg, which is this one, and say y2 minus y1, oh my gosh, Miss Waite, I'm thinking 3 steps ahead, squared equals the length of that segment squared, c squared. C is actually called AB, and so let's replace that C with the name of this segment, AB. And that, right there, is the distance formula. That's what it looks like. All you're doing is finding the length of A, or the length of one side, one leg of the right triangle, squaring it, adding that to the length of the other leg and squaring it, and that's going to be the length of that hypotenuse leg, or the hypotenuse side. Now, don't worry, I'm never going to ask you this. I'm never going to ask you to recreate it. But I just wanted to kind of show you that this is how formulas get started. Somebody has to think about, okay, how does this get done, and how does it get done every time? And when they find a method that works every single time, they turn it into a formula. And then we can use it. And we don't need to know the deep, dark background of the formula, but we just need to know that it works. And this one does. So there's one more thing to tell you, because our book actually expresses this distance formula that we have right here in a slightly different way. Now don't pick up your pencil yet, because this is what the distance formula looks like in your book. Now I'm going to write how we had it on the other slide here real quick. You see the difference between these two things? We're going to be using the one that your book, or the Big Ideas Math, uses, but they're exactly the same. Because, as you know, with all algebra problems, you can do the same thing to both sides. So if I took the square root of this side and the square root of this side, doing the same thing to both sides, what I'd have is the square root of x2 minus x1 squared plus y2 minus y1 squared equals the square root of ab squared is just ab. And that's what we have here. So they're really saying exactly the same thing. It's just a different form. And so we're going to use the one there at the top that says the distance formula AB equals the square root of x2 minus x1 squared plus y2 minus y1 squared. And that is what you're going to take a moment to write in your notebook. So pick up your pencil and write down that formula, and then we'll use it. All right, if you didn't have enough time, you can always pause. Now, like I said before, really, I just showed you how you get the formula, but I'm never going to ask you to do that. I just wanted you to see where it comes from. What you're going to do is know the formula in this particular form that you see in front of you and how to use it. And so here is that. So we've got a problem, an example. Find the distance between the points A and B. A is at 14, -5, and B is at 8, 2, and we want to find how long that segment is. And so we're going to use the distance formula. So we're going to write down AB because that's the length that we're going to find, and that's going to equal, and then please do yourself a massive favor and make a big square root symbol. I cannot tell you how many times I've seen students leave that square root symbol out, and then they get the answer wrong every time, and they don't understand why. Now we're going to get into this x2, x1 stuff. Now, is that familiar from something? Maybe the midpoint formula? Same thing. x2 and x1, y2 and y1 all come from the points that you see in front of you. So this point, A, has your x1 and your y1. B has your x2 and your y2, and now you're just going to take those numbers and jam them into the formula. So the formula asks you for x2 first. So what's the value of x2? Well, I can see that it is 8. And then the formula asks us to subtract. And then we need the value of x1, 14. And then some parentheses, and then we're going to square. And then we need a plus sign. And then we need more parentheses. And now we need the value of y2. There it is. It's 2. Minus y1, which is -5. Minus -5. Close the parentheses. And make sure you don't forget to square. Now, when you are subtracting a negative, that's the same as adding. So this should be 2 plus 5. Remember that? Okay. So now you just calculate. Remember that you want to take care of what's inside the parentheses first. If you can, order of operations starts with grouping symbols. And so AB has to equal big old square root, whatever 8 minus 14 is. 8 minus 14 is -6. Now I'm going to leave these parentheses for a reason that you'll see in just a second. Now don't forget you still haven't used that exponent, so bring it on down. Plus 2 plus 5, which is 7. And again, I'm leaving the parentheses, and you'll see why in just a second. And don't forget that squared symbol. So we've taken the first step. Simplify inside the parentheses. The reason I left the parentheses is because I want to point something out to you. When we're looking at this right here, when you are squaring a negative, if you have a calculator handy, you can just punch -6 squared into that calculator. Now, depending on the calculator you're going to have, -6 squared might be 36, and -6 squared might be -36, and you need to know which one is right. It turns out this one. And your calculator probably gave you that, because this symbol, -6 squared, to your calculator means the opposite of whatever 6 squared is, which is the opposite of 36. But what you really want is -6 times -6, which is -6 squared. A negative times a negative is positive, and so you have positive 36 here. Now that's exactly why I leave the parentheses, because it reminds me that I am squaring not only the 6, but also that negative. And so AB is going to equal the square root of 36, not negative 36, plus 7 squared, which is 49. And the parentheses aren't super useful around positive numbers, but I just try to be consistent. I mean, math is all about those little pitfalls, and if you can figure out a way for you to remember how to not fall into the pitfalls, it can be very helpful. All right, so we're almost done. AB is going to equal the square root of whatever 36 plus 49 is. So we got, let's see, 36 plus 49, and yeah, I'm using a calculator, why not? 85. That's the worst 5 ever, but you get the idea. All right, and then you know what? You could leave it like that if you want to. Square root of 85 is a beautiful number, but most of you will want to go ahead and take the square root of 85. I don't blame you. If we were in class together, I would be explaining to you all kinds of reasons to leave it as square root of 85, but we're not, and so we do what we do. So I'm going to take the square root of 85, enter, and I get 9.22, let's say, units. And so we know that that segment is 9.22 units long. That's how you do it. So it looks really complicated, and there are a lot of pieces. So practice is important. So let's try another one. Find the distance between the points -4, 5 and 7, 9. Now again, you have the distance formula, which says the distance between 2 points is the square root of x2 minus x1 plus y2 minus y1, and then both of those are squared. So now I'm just going to plug in some values. Well, I know that this is x1 and that one's y1, and this is x2 and y2, and once I have those values, I can put them right into the formula. So the distance between A and B is going to be equal to the square root of x2, which is 7, minus x1, which is -4, so plus 4, and those are going to be squared, plus y2, which is 9, minus y1, which is -5, and we square it. Remember, subtracting a negative turns it into addition. So now that we've plugged those numbers in, we can simplify within the parentheses. The distance between A and B is going to be equal to the square root of 7 plus 4, which is 11. Don't forget you got to square it. Plus 9 plus 5, which is 14. Square it. And now, again, these parentheses aren't super useful right now because there's no negative numbers to make mistakes with, but I leave the parentheses until I do the squaring so that I don't make mistakes. It's all about developing some consistency. And then the length of AB is going to be the square root of whatever 11 squared is. That's 121, actually. I knew that one. Plus whatever 14 squared is. 14 squared is 196. Okay, one step to go, or two if you want to turn it into a decimal. AB is going to be the square root of 121 plus 196, which is 317. Okay, take the square root. AB is the square root of 317, and that is about 17.8. Rounding is a thing. I like to round to 2 decimal points just because it's more exact. It's closer to the right answer. But we got 17.80449,381, and so that 0 after the 8 isn't really necessary. So 17.8 is good enough. And now we know that this segment is 17.8 units long. So you can see that you can do this. It's kind of like the midpoint formula. Identify those numbers, x1, y1, x2, y2. take those and put them in the right spot, and then just follow the order of operations. Take care of the parentheses first, then take care of your exponents, then take care of the addition, and at the end, you'll take the square root. So here's a kind of a word problem that goes along with this. Now, a lot of y'all skip word problems, and I understand. It's a little tricky, but this is just going to be a distance formula problem. Let me show you how. So your school is 4 miles east and 1 mile south of your apartment. And so we're assuming that your apartment is right here, and your school is 4 miles east, 1, 2, 3, 4, and 1 mile south. So here is your school. Here's your apartment. All right, and then it says a recycling center where your class is going on a field trip is 2 miles east and 3 miles north of your apartment. So 2 miles east, 1, 2, and 3 miles north, 1, 2, 3. There is the recycling center. The question is, estimate the distance between the recycling center and your school. So in other words, find the length of this segment, right? Well, if you want to find the length of that segment, you have this handy-dandy little formula, not so little, but you have this formula. The distance between 2 points is going to be the square root of x2 minus x1 squared plus y2 minus y1 squared. And if we know those points, we can jam them into that formula and do some calculating. Well, your school is at negative 1, 2, 3, 4, negative 1, negative 4, 1, sorry, negative 1. And the recycling center is at 1, 2, 3, 1, 2, positive 3, negative 2. And now we have our points. Here's our x1, y1. Here's our x2, y2. And now we can jam those numbers into this formula. So the distance between the 2 points, and we're just calling them generally A, B, is going to be the square root of x2, which is 3, minus, oops, I forgot my parentheses, 3 minus x1, which is negative 4, so 3 plus 4 squared, plus y2, which is negative 2, minus y1, so minus negative 1 or plus 1 squared. Just put the numbers right in. So now we calculate within these parentheses, AB equals the square root of 3 plus 4, which is 7 squared, plus negative 2 plus 1, which is negative 1 squared. And here's a time when the parentheses are a little bit useful to make sure that you don't forget about that negative. So the distance between A and B is going to be the square root of 7 squared, which is 49, plus the square of negative 1. Negative 1 times negative 1, or positive 1. And now, add those two up. It's going to be the square root of 49 plus 1, or 50. And the last step, find the square root of 50. Second square root 50, 7.07. So it's about 7, what are the units? Miles. There you go. It's about 7 miles from your school to the recycling center, and that's how you figure that out. All right? So the distance formula is a thing, y'all, and it looks intimidating, but you can do it. It's just a matter of identifying your points, labeling them with the x1, y1, x2, y2, sticking those numbers in the right spot, and then calculating your way through this problem. All right, friends, that's the distance formula for you. You've got some practice on big ideas math. The assignment is called the distance formula. The essential question was, how can you find the length of a line segment in the coordinate plane? And now you know the answer to that question is you use the distance formula, y'all. I hope you have a wonderful day and that now that you're done with a little bit of geometry, you go outside and enjoy some, something fun. Okay, I'll talk to you when I talk to you. Bye.